Although experiments in your science and math classes versus your humanities and social science classes might look a bit different, really, experiments in both classes follow a kind of non-linear experimental process. Before we can do anything, we certainly need to define the problem. After we define the problem, we need to design solutions. Then the fun part begins. I like to use a term that comes out of kind of the Silicon Valley mentality of iterating. This is 1R, by the way, where you take your design solutions and you refine, redesign, retest in various ways your design solutions until it's just right. Obviously, we need to worry about measurement. And then science would be nowhere if we didn't think about how we presented our data. So what does this look like in the STEM classes, so your science and math classes? Well, when we define the problem, one thing that we really need to keep in mind in order to make experiments a constructivist activity for our students is that we want them to focus on real-world contexts. While certainly how copper interacts with heat is a real-world context, you can't get more real-world than some of those basic elements. Putting them in terms that our students are going to understand and be able to see the applications to our modern world is really important. Once we have the problem defined in science and math, we need to start designing some solutions. To make this a constructivist activity, it's possible to have students come up with some ideas themselves. Oftentimes when we take a look at our curriculums or curricula, we have a pretty basic outline of a science lab that we want to do. And you know, if you look at math, the math textbook's pretty prescriptive. But having students come up with alternate solutions it really would help with helping them identify what design actually looks like. And obviously we would have to iterate, so refining those alternate solutions so that it's an appropriate lab or get similar results to the initial lab would be important. When it comes to measurement, something that I don't find a lot of science teachers thinking about is having students explore various types of measurement. How we measure things really tells us how we relate to the world, and allowing students to explore various types of measurements and what that would mean for their findings would be really important. And finally, when we're having students present, obviously there's a big push for graphs and how math is applied and how to do these scientific ways of expressing science and math experiments. It's also important to think about art and how art can be used to reach some of those students who don't have necessarily a strong grasp in some of those more analytic, quantitative ways of expressing themselves, and actually how art might encourage students to think about their numbers and their data and their findings in a deeper way. This is, if you're interested, a really great scientist named John Bonanen, I can never pronounce his last name, did a TED Talk about using dance as a way of expressing scientific findings. On our social side, for our humanities and social sciences, defining the problem looks a little bit different. Instead of worrying about real-world context, we definitely want to think about student experiences and this is a big and, what experts do, or experts' actions. Thinking about what problems there are in the students' lives and the students' communities, and then also how experts actually approach these problems will help us define the problems themselves. In designing solutions, we want to think about how to share project videos, experiences, and develop new approaches. So I'm going to put down videos and experiences that either the students have or the experts have to define new approaches. Just because one type of experience or one type of action worked well in a particular place at a particular time doesn't mean that it's going to work in ours. And having students understand the similarities and differences between experiences is really important for both English and social studies students to understand. For iterating, we want to have our students test various solutions and provide time for retesting. This is something that I don't think, as a social studies teacher myself, I understood quite the impact of what iterating can do for a social studies or an English class. Asking students to come up with various solutions to our defined social problem and testing them in small groups or testing them using their own experience really will allow students to get a sense of what works, what doesn't, and then you get a really great time to think about why something worked and why something didn't. When it comes to measurement, I'd encourage teachers to use technology as much as possible as a way to interact and gather data. I loved going out as a student and doing interviews. It was even more fun, though, being able to post those interviews online, getting our projects, word about our project out, but also getting a chance to learn the technology and learn how technology can actually make some of the more laborious qualitative work that much easier. And finally, for presenting, I think people in English and social studies need to think quantitatively as well as qualitatively. Many projects that I see and I have asked my students to do have really used art or a writing project. It was some qualitative way of presenting some things. But using numbers can be really powerful too and make great connections between the STEM and the humanities and social sciences.